So welcome to Spark Tutorials. Okay, today we will discuss what is Spark and what are the components, what are the tools included in Spark, like Spark SQL, MLib, Spark Streaming, graphics and all. Okay, before talking about all these tools, let's start with what Spark is actually. Spark is an open source big data processing framework built around speed, um, ease of use and sophisticated analytics. It was originally developed in 2009 in UC Berkeley MP Lab. Okay, and open sourced in 2010 as an Apache project. It was open sourced in 2010. Spark has several advantages when it compared with other big data and MapReduce technologies like Hadoop, Storm, okay, Teradata, like that. Sparks gives us a comprehensive unified framework to manage big data processing requirements with a variety of data sets that are diverse in nature as well as source of data, that is batch versus real-time streaming data. Spark enables applications in Hadoop cluster to run up to 100 times faster in memory and 10 times faster even when running on disk. Okay, Spark lets us quickly write applications in Java, Scala, Python, and the recent versions of Spark supports R statistical language also. It comes with a um, built-in set of over 80 high-level operations, and you can use it interactively to query data within the shell. That is a user interaction mode. Okay. In addition to map and reduce operations, it supports SQL queries, streaming data, machine learning, and graph data processing. Developers can use these capabilities standalone or combine them to run in a single data pipeline use case. And now, in this section, we will look at what Spark is and how it compared with the typical MapReduce solution and how it provides a complete suite of tools for big data processing. Okay, we just give a introduction, and the later sections we will explore what exactly Spark is, how it works in application oriented. I will teach you. Okay, for this discussion I'm going to compare both Hadoop and Spark. Okay, yeah. Hadoop and Spark. Hadoop is a big data processing technology, has been around for 10 years and has proven to be the solution of choices for processing large data sets. MapReduce is a great solution for one-pass computations. It's a batch-oriented processing technology. It's a code tool in Apache Hadoop framework, but not very efficient for use cases that require multi-pass computations and algorithms. Each step in the data processing workflow has one map phase and one reduce phase, and you will need to convert any use case into MapReduce pattern to leverage this solution. It supports only the application that processes mapper and reducer phases. Okay, then only that application will be processed by the Hadoop framework, especially with the MapReduce framework. The framework is designed with two phases, map phase and a reducer phase. Whatever the application, it should be converted into map and reducer phase to process that particular data use of that particular application. The job output data between each step has to be stored in the distributed file system before the next step can begin. the intermediate values. The intermediate values will automatically get stored in a disk in Hadoop framework. Hence, this approach is obviously you can think of it. This approach tends to be slow due to replication and disk storage. I already told you, intermediate results are storing in disk. That is automatically happening process in Hadoop. So, and also Hadoop solutions typically include clusters that are hard to set up and manage. And every time, whenever we need another mission, we should set up that. We should include that mission into Hadoop cluster, and it requires so many configuration changes, and it's very hard to manage and very hard to set up Hadoop cluster. It also requires the integration of several tools for different big data use cases like Mahat for machine learning and Storm for streaming data processing and for graphical analysis, graphics, and for structured data maintenance, um, like that. If you wanted to do something complicated, you would have to string together a series of MapReduce jobs and execute them in sequence. Suppose when we talk about the Apache Hive, user simply developer simply write a queries based on his requirements, application requirement. But internally, what happening? That queries will automatically converted into MapReduce jobs. Okay, I'm just giving user satisfaction. Okay, if non-Java guy want to develop an application using a Hadoop framework, what he can do is just take the third-party tool like Apache Hive and just to write some queries, and he will execute. But internally, those queries are converted into MapReduce jobs. So without MapReduce, we cannot do anything in Hadoop framework. Okay, and each of these jobs I already told you converted. Spark allows programmers to develop complex multi-step data pipelines using a directed acyclic graph drag pattern. Okay, it's analyzing the data structure is a drag pattern. It also supports in-memory data sharing across DAX, in-memory data sharing. And those are intermediate outputs and any other data can easily stored in memory. Um, so the different jobs can work with the same data. Okay, the data is stored, cached, or persisted in memory while running different jobs. Those jobs can easily read the data from in memory very efficiently, very fastly. Okay, runs on top of existing Hadoop distributed file system. In for existing Hadoop distributed file system to provide enhanced and additional functionality. Okay, both the Spark and Hadoop distributed file system gives us better performance than other integrations. It provides support for deploying Spark applications in an existing Hadoop 1 cluster or with the Hadoop 2 cluster. Hadoop 2 cluster in the sense it will completely managed by the another resource a negotiator, cluster resource manager, or for or even with Apache Mesos. Okay, we should look at Spark as an interactive to Hadoop MapReduce rather than a replacement to Hadoop. Okay, Spark is an alternative to Hadoop MapReduce. Just it's not a replacement of Hadoop. Both are different ecosystems. Of course, Spark is not an ecosystem; it's just a processing engine. Okay, it is not intended to replace Hadoop, but to provide a comprehensive and unified solution to manage different big data use cases and requirements. Yes, yeah, and this is all about Hadoop comparing with the Spark, and both. So my conclusion is that Hadoop is just a framework. It includes different storage layers and processing layers and monitoring and data ingestions too. The different for different category there is a different third-party tool in Hadoop framework. But in Apache Spark, it's not a framework, it's just a cluster computing processing engine. Just a processing engine, that's it. There is a nothing in Apache Spark, it's just a processing engine. There is no storage layer for the Spark. But in case of Hadoop, there is a storage layer, that is HDFS. Okay, so direct comparison between Hadoop and Spark is not the direct discussion. It's meaningless because it's a framework. It and the Spark is an execution engine. But when you're comparing Spark with one of the core processing component of Hadoop tool, that is MapReduce, is meaningful. When you compare MapReduce and Spark, gives you better understanding what exactly MapReduce processing engine is and what exactly Spark processing engine is. How does Spark makes its application to be better performance? Okay, now just I wanna just give you a short introduction on Spark features and what are the tools available in Spark. For what is what, I'll just give you some minutes of introduction. Spark takes MapReduce to the next level with less expensive shuffles in the data processing, um, with capabilities like in-memory data storage. I already told you on Spark, most of the data are stored in memory. It persisted or cached in memory only, so that so many applications while running their jobs take that persisted data and perform applications very easily or very fastly. Everything is a tiny matter here. Okay. And the performance can be several times faster than other big data technologies. So like this way, Spark also supports the lazy evaluation of the big data queries. Okay, which helps with the optimization of these steps in data processing workflows. It provides a high-level API to improve developer productivity and a consistent architect model for big data solutions. Okay, and one thing you should remember, um, Spark holds intermediate results in memory, rather than writing them to the disk. I'm saying this word almost 3 or 4 times. You have to remember this. Why Spark is most efficient than Hadoop means Spark holds intermediate results in memory rather than writing them to disk, which is very useful, especially when you need to work on the same dataset multiple times. Okay, it is designed to be an execution engine that works both in memory and on disk. Spark operators perform external operations when data goes not fit in memory. Okay, it can use disk space also when memory in memory are not available. Spark can be used for processing data sets that larger than the aggregate memory in a cluster. Okay, and Spark will attempt to store as much data as in memory, most of the data in memory, and then will spill to disk. If RAM is not available, then it will spill to disk. It can store part of your data set in memory and the remaining data on the disk. So you have to look at your data and use cases to assess the memory requirements. With this in-memory data storage, Spark comes with performance advantage, and including with this, there are some other features. It supports more than just map and reduce functions, optimizes arbitrary operator graphs, lazy evaluation of big data queries, which helps with optimization of the overall data processing workflow, provides concise and consistent APIs in Scala, Java, and Python, and it offers interactive shell for Scala and Python. This is not available in Java till now. Okay, Spark is written in Scala programming language. We know that already, and runs on Java virtual machine environment. It currently supports some languages. So those are Scala, Python, Java, and R. Okay. Okay, that's it for the introduction of the Spark in this tutorial, and we will uh, we will discuss more in depth in Sparky ecosystem in next video. Please subscribe and please follow my videos. Okay. Okay. Okay, thank you.